Happy Thursday, 6th grade. Today we're going to continue working with triangles, now focusing on finding the area of acute triangles using height and base. Our objectives today are that we can show the area formula for a triangular region by decomposing a triangle into right triangles, and that we can understand that any side of a triangle can be considered a base, and that the choice of base determines the height. Let's start by looking at two different triangles. The triangle on the right is a right triangle and has an area formula of 1/2 times base times height. The triangle on the left is an acute triangle. This is going to be our focus for today's lesson. Let's zoom in on this acute triangle. When labeling the dimensions of the acute triangle, we can still measure its height, also known as altitude, and its base. Notice that the height is still a vertical line that runs perpendicular to the base. When looking at the height, you may observe that this actually cuts our acute triangle into two smaller right triangles. This is going to be important for finding our total area. Yesterday, we talked about how to calculate the area of a right triangle using the formula 1/2 times base times height. Here, we have two right triangles. We're labeling the blue right triangle's area as A1, or area 1. We're labeling the red right triangle's area as area 2, A2. We've also divided the base of our big acute triangle into two parts, base 1 and base 2. Let's go ahead and substitute real numbers into this model. We can begin by solving for the area of the blue right triangle using our area formula we developed yesterday. I see that the base of the blue triangle is 5, and the height, or altitude, is 3. Let's substitute these values into our formula. We now have 1/2 times 5 times 3. Pause the video here while you solve for the area of the blue right triangle. Five times 3 equals 15. 1/2 of 15 is 7 5/10. The area of our blue right triangle is 7 5/10 square units. Let's repeat this process for the red right triangle. We see that we still have a height of 3, but the base of the second right triangle is 1 5/10. Substitute these numbers into our formula. Find the area of the red triangle by solving the equation. 1 5/10 times 3 equals 4 5/10. Half of 4 5/10 is 2 25/100. The area of the second triangle is 2 25/100 square units. To find the area of our entire acute triangle, we need to add the area of the parts we broke it into. Let's add 7 5/10 plus 2 25/100. The area of our acute triangle is 9 75/100 square units. Not bad, but I bet there's a faster way to find the total area of an acute triangle. Let's look back at our area equations for the two right triangles, but this time with some small adjustments. This area formula represents the total area of our acute triangle. The part of the formula in blue is the same as the area formula for the blue right triangle. The part in red is the same as the area formula for the red right triangle. This is exactly the same as us adding the total areas of each right triangle. We just broke it down to show them before they had been solved. We're going to focus on simplifying this formula to something we can apply to all acute triangles. The first thing I notice is that both quantities in parentheses are being multiplied by 1/2. The distributive property of multiplication allows us to combine these terms and instead place the entire formula in parentheses to be multiplied by 1/2. This does not change the value of our formula. Next, observe that we are multiplying groups of 3 on both sides of this expression. We're adding 5 groups of 3 and 1 5/10 groups of 3. Because we're multiplying groups of the same amount, we can combine 5 and 1 5/10 for 6 5/10 groups of 3. We show this as 6 5/10 times 3. Our formula looks a lot less confusing now that we've combined like terms. Notice that we derived 6 5/10 from the total base of the acute triangle, adding 5 and 1 5/10 together. You may also see that our 3 comes from the height of the acute triangle. This was the same height as both of our right triangles. This means that to find the area for our acute triangle, we can use the formula 1/2 times base times height, the same formula we use for right triangles. Before we go, try a new example on your own using our 1/2 times base times height formula. Pause the video here while you substitute our values into the equation and calculate the area. We have a base of 8 and a height of 5. 8 times 5 is 40. 1/2 of 40 equals 20. This triangle has an area of 20 square units.